Here we are going to see the implementation of logistic regression using Python. Now for implementing logistic regression in Python, we'll be using packages like NumPy, Pandas, as well as a machine learning package called as scikit-learn. Now first of all, the problem statement. Okay, so what we are going to work around here. So basically first let us define the problem statement. So here we have to predict if a person is going to buy insurance or not based on his or her age. So this is our problem statement here. So we have to predict if somebody is going to buy insurance or not based on his or her age. So now to do that, we need a data set. So we are going to use a data set here, which will be having age of different people as well as if they bought insurance or not. So here either they bought insurance or not will be in 0 or 1 format. Okay, so let us first import the required packages. So here we'll be needing NumPy, Pandas. We will also import matplotlib. So first of all, what we have to do here is we will be reading the data set and we'll be converting it to a data frame. So data set is in CSV format, and here it is there in datasets folder, and basically the dataset name is insurance_data.csv. You can either download it from internet, this dataset, and you will also find it in the GitHub repository. Okay, you can download it from there. So once I run this, let us see how many data are there. In this data set, we have total of 27 records with 2 columns. So let's say the top values here. So df.head shows us top 5 records. Here we can see that we have age column and the other one is bought insurance or not. So bought insurance 0 means that person didn't buy insurance, and bought insurance 1 means that person bought the insurance. Okay, so now this is our data which is in binary format. So this is a classification problem, because you can see in the dependent variable here, our dependent variable or the target variable is bought insurance or not. Independent variable is the age. Okay, age is the independent variable. So here we have to predict if a person is going to buy insurance or not based on his or her age. So first we have to study the relationship between age and buying insurance. So here we cannot use linear regression, because if you look at the data, okay, let's look at the data, how it looks like when we put it in scatter plot. So when we put this data in scatter plot, so let's take age and bought insurance. So when I take this data and put it in scatter plot, you can see that we have values at 0 and we have values at 1, and in the x-axis we have the age values. Okay, so here age values are defined in the axis x. So let's also give some title and all those. So let me give a title, x label. So we'll say x-axis is the age values, y label is our bought insurance or not. So this is what is there. So bought insurance or not, either 0 or 1 in our y-axis and age in our x-axis. So we can see that the values are either 0 and 1. So here we cannot find a straight line. Okay, we cannot just use a straight line. We cannot fit a straight line to our observed data points. We'll have so much of errors. So here we are going to use logistic regression. So in this kind of scenarios, we can use logistic regression. Now, before we use logistic regression here, what we will do is we'll be dividing our data into two parts. So we have 27 records here. So we will divide the data into two parts where we can use some data for testing as well as the other data for training. So we'll be using specific data for training. Suppose you say 80% of the data for training, rest 20% of the data we will keep for testing so that we can validate our model. So we'll be using logistic regression on top of our data and we'll train suppose 80% of the data. Rest 20% we'll keep so that we can validate and see how good our model is performing. Okay, so we'll be looking at training as well as testing. Okay, so in training, the what is the accuracy behind, also in testing, what is the accuracy. So we'll see both the accuracies in training as well as testing so that we'll be able to compare how good the model is predicting. So here what I will do for the same thing for train test split, we'll be using scikit-learn package. So in scikit-learn, there is something called as model selection. In that we have train test split. So we can use this particular train test split from scikit-learn package, okay, for splitting our data. So when we to do that, basically we'll be using this train test split and we have to tell what to split. So we have to pass our x data, so independent variable. So you have to always pass the data in two-dimensional format. So I am just using two brackets here, and the other one is bought insurance or not. This will be in one-dimensional format. Sorry. So bought insurance or not. And here we also have to mention the test size. So here I will say test size is 0.2, means 20% of the record for testing, rest all for training. And we have to put it in a variable here. We have to store all this in a variable. So we'll have four variables here. Xtrain, first one is xtrain, second one is xtest, similarly third one is ytrain, fourth one is ytest. So always you have to follow this pattern because the return of this train test split will be in this format. So first it will give us return type will be in array format. So first index of that array will hold all the training data, second one all the testing data, then again ytrain and ytest data. So like this we have to keep. So once we do that, let us check some test data. So here when you say xtest, we can see there are total of 6 records. 20% of 27 is 6. So we have total of 6 records for our this one xtest, that is for testing. As well as if you look at ytest, here also we'll have 6 predicted values. So for the first age it says 0, okay, like that. So let me just write it like this. Okay, it's much better. So xtest and ytest. So for 26, that is the age group of 23. Okay, this 26 is nothing but the index. Age 23, it says bought insurance or not, it is 0, means 23 age didn't buy insurance, 25 age bought insurance. So like that we have certain testing records also. If you look at the training record, similarly, so here testing record, if you see xtest dot shape, we have total of 6,1, so 6 values. If you look at xtrain dot shape, we have total of 21 records in the training data. So we'll be using these 21 records for creating our model and this xtest 6 records for testing our model. So for training our model, okay, so here let's train on logistic regression and check the prediction. Now for doing that, we'll be using logistic regression. So first we have to import So from scikit-learn, okay, so we'll be using scikit-learn. In linear model, inside linear model, we have this class called as logistic regression. So we'll be using this. Now for creating the model, we'll create the model saying model equals logistic regression, and this is our class, so we'll be creating an object, then model.fit, and we'll be fitting our training data here. So we'll be passing only training data because we are going to create the model on training data, and we are going to predict on test data. We are going to check everything on test data. So once we do model.fit, okay, let me check. Okay, so logistic regression, it is correct. So model.fit we have done. Now here we have tried to fit the logistic function to our training data. Now next is we will see model.predict. Okay, now for checking the prediction for our test data, okay, is it able to predict the test data or not? Let's check. Okay, it is predicting the test data. Okay, so we are able to predict the test data. You can also predict the train data. Now here if we look at x test value, okay, if we take the x test value, we know that in x test value we have this age 23, 25 like that, and we already know that in y test value we have all the observed actual data values. So for 23 age didn't buy insurance, that's what here it says. Now when we try to predict the x test value, this is the y pred values. Okay, so this is y test value, this is the y pred for the same. Now here we can try to match and see, okay, how close it is. Now for 26 years old, earlier for observed value for the previous one, okay, for the age 23, observed value was 0, but when we predicted also it says 0, that means it is correct. Okay, so our prediction is matching. When you look at age of 25, okay, age of 25, okay, first one is 23, next one is age of 25 actual observed value was 1, so that 25 years old actually bought insurance, but when we predicted it says 0, means didn't buy insurance. Okay, so it has predicted here something different. Okay, so which is different. So now if you want to see the probability behind each of the prediction, because we know that logistic function is nothing but it's mapping probability to our observed data points. Now if you want to look at the probability values, you can use a method here called as predict_proba. So this will show you the probability behind each of the prediction. So probability for 0, first one is probability for 0, second one is probability for 1. So first index is probability for 0, second index is probability for 1. So we can see probability for 0 is 93% for the first data. So that's where we got 0. Okay, more probability for 0. Second one also probability is 91%, okay, for 0. So that's where we got 0 here. Okay, so for age 23 probability for 0 is higher. For age 25 also we saw probability for 0 is higher. Similarly, if you look at the last one where we are getting 1 as the output, that is for age 60. So for age 60 probability for 0 is only 4%, but probability for 1 is more than 95%, almost 95%. So that's where probability for 1 is more, so we got 1 as the output. So you can also see what is the probability behind each of the prediction. If you want to predict for certain age, suppose I want to see for myself, I want to predict for age, I'll say age of 35. I just want to see if 35 years old will buy insurance or not. It says no. 35 years old, it gives me 0. That means 35 years old is not going to buy insurance. If I say 50 years old, it says 1. Okay, 50 years old is going to buy insurance. So that's what it is predicting me here. Now let's check the score behind this model. Okay, so we have seen how to do the prediction and we predicted for test values. So we can check the score for training as well as test data and match this score here. So I will pass here x train and I will pass here y train. So it shows 857, almost 86% score is there, accuracy is there behind the model. Now if I check the score for test data, let's see, okay, how near it is. We are getting 83%. So almost very close. That means like model is very much stable. It's almost very close to the training data's accuracy. So in training data anyways, accuracy is going to be a little bit higher. Sometime in test also it can be higher. Now in training we are using the data which we have already trained. So same data we are using for prediction. So in score, what it does, it will use the predicted values as well as the observed values, and it will see how close it is. But when it comes to test data, we have not trained the test data, so we are just trying to predict the test data, and we are trying to compare with the observed value. So here it's always better to look for the score for the test data, okay, which are not trained, which model doesn't know, model is not aware of our test data. So now in test data we are getting 83% accuracy, which is very close to the trained data. So here we can say, okay, it is very much near. So model is stable, and 83 to 85% is the accuracy behind the model. Okay, this is how you can implement logistic regression using Python scikit-learn package. Thank you.